Welcome to the Atheists of Florida YouTube channel. We are pleased to offer some of the most significant speakers and profound issues of our times. If you like today's video, please hit the like button. If you have already subscribed, thank you. If not, you know what to do.
Okay, first of all, that sounds exciting. Eugenie Scott. I mean, I have some books from her and I've seen her on, YouTube and stuff like that. That's cool.
Great.
Okay, let me see if I can share my screen. This is the second PowerPoint presentation I've done in my life, and the last one was 14 years ago. So it's probably not going to be like professional like you guys are used
Don't
to.
worry about it. I'm sure your talk will be even the more interesting for it.
Okay, so my presentation today is common counters to evolution and how they fail. I won't be able to get through all of this probably. I don't know. When I was doing my timings, it took a little longer than I expected, but let's get started. Okay, so the first counter to evolution is, this is a whole series of things here. Evolution is just a theory. You hear that a lot. Notice how scientists always refer to it as a theory of evolution, never the law of evolution. That's because evolution is unsupported speculation. If evolution had been proven, it would have been promoted to a law, and scientists will call it the law of evolution. So now I go to the counters to their counter, why their counters fail. First of all, in science, theories and laws are two different things. One can't become the other. Simply put, laws are descriptive and theories are explanatory. Laws describe what happens under a certain set of conditions, whereas theories explain how or why it happens. I'm not going to read that. That's just something if anyone wants to read it when they review this, whatever. That's just exceptions to, because sometimes the words theory and law are not used correctly. So this is the typical case, is the difference between Newton's law of universal gravitation and Einstein's theory of general relativity, which is a theory of gravitation. Newton's described what happens. You plug some numbers into an equation, a formula, the mass of the Earth, the mass of the moon, and the distance, out pops the value. That's great. It describes what will happen, but there's no explanation in here. Gravity, to Newton, gravity was just some mysterious force that supposedly reached out across hundreds of thousands of miles of empty space instantaneously and pulled the moon towards the Earth. And when he was asked, he wasn't asked, but in his book, he was trying to explain it. And he said, I have not as yet been able to discover the reason for these properties of gravity from phenomena, and I do not feign hypotheses. In other words, he had no idea how gravity worked, but he still had a perfectly valid law. In 1915, Einstein published work on his general theory of relativity, which is basically a theory of gravity. In Einstein's theory, gravity is the curvature of four-dimensional space-time. Objects, mass, energy, pressure, things like the sun, the Earth, they warp 4D geometry of space-time in their vicinity, and then other objects in motion follow the straightest possible path through the deformations. So a typical 2D analogy that's given is, sometimes you'll see it visually, they'll take a rubber sheet and stretch it taut. You take a marble and you roll the marble on the sheet and it follows a straight line. Now you take something massive like a bowling ball and set it in the middle of the sheet, and that deforms the sheet around it. Then if you roll the marble, it no longer follows a straight line, it follows a curve. If there was no friction between the rubber sheet and the marble could actually stay in an orbit around the bowling ball. And this is the general image. Thing center could be anything such as the Earth, and then the thing orbiting it would be the moon. But this was the general idea of Einstein's general theory. And he gave an explanation. It was no longer a spooky force that reached out magically across space and pulled on something. It was now the deformation of space-time itself. So theories give understanding, laws just described. And that's the next part. The second problem with theirs is that in science, theories are at a higher level than laws are. Newton's law of gravitation merely described gravity. On the other hand, Einstein's general theory of relativity explained gravity, and with it, scientists had a much better understanding of gravity and how it worked. So if it were true that one could be promoted to the other, they can't. But if it were true, then laws would be promoted to theories, not the other way around. And then finally, the main core of their objection is that's all like technicalities. But the big problem with their argument is that it is not true that evolution is unsupported speculation. There's tons of valid, objective, positive evidence supporting evolution from various fields. I could give a long presentation on just the evidence supporting it, but that's a completely different matter, so I won't be doing that. But then you may ask, well, if evolution really does have so much good evidence supporting it, then why isn't the theory of evolution considered to be proven? That's because it's science. The methods of science cannot prove anything. In the negative case, the methods of science can disprove a scientific theory, but they can't prove one. In the positive case, they can only add additional support to a theory. So in other words, the fact that the theory of evolution has not been proven is not a problem because as a rule, no scientific theory is ever proven and none ever will be. That gets into the philosophy of science, which I'm not going to get into here, but proof. Anyway, never mind. There's a difference between evidence and proof. So this is a summary. Their argument is evolution is just a theory. Notice how scientists always refer to it as the theory of evolution, never the law of evolution. That's because evolution is unsupported speculation. If evolution had been proven, it would have been promoted to a law, and they would call it the law of evolution. So the three problems are theories and laws are two different things. One cannot be converted into the other. Theories are actually above laws. So if one was promoted to the other, laws would be promoted to theories. And it's simply not true that evolution is unsupported speculation. The second counter that they often bring up is evolution, which involves an increase in order, like increasing complexity over time, that it violates the second law of thermodynamics, which they often call the law of entropy, which says that everything changes in the direction of greater disorder. To start with, we have to understand there's three different types of thermodynamic systems. The red arrows indicate whether energy can enter or exit the system, and the purple arrows indicate if matter can enter or exit the system. So the three types are open, closed, and isolated. A thermodynamically open system is one that can exchange both matter and energy with its surroundings. Living organisms, such as us, are open systems. For example, when we eat food, we are bringing in matter and energy into our body. When we urinate, defecate, we're releasing matter into the surroundings, and our body is continually radiating heat to the surroundings. So we are open systems. A closed system, for example, is when you make sun tea. You take your ingredients of tea, you put it in a clear jar, put it outside, you seal it so nothing gets in or out except for energy from the sun. And then the final is an isolated system, and that's one where neither energy nor matter can enter or exit the sun, and the system, sorry. And the universe as a whole is considered a thermodynamically isolated system. Nothing gets out of the universe, energy or matter, nothing comes in from the outside. So I'm going to, there's several different ways to describe entropy. I'm going to stick with the anti-evolutionists, which they usually describe as disorder. Sticking with theirs, it does not say that everything changes in the direction of greater disorder. That only applies to thermodynamically isolated systems. If the total entropy disorder of a thermodynamically isolated system changes, then it must increase. That's important. The mandatory increase applies to isolated systems, not open ones. In open systems, you can have local decreases in entropy. In other words, the amount of order can increase. The second law of thermodynamics fully allows for local decreases in entropy. And it occurs spontaneously with no intervention from an intelligent being. It just happens. The only requirement is that for a local decrease in entropy to occur, the entropy of the surroundings must increase to a greater degree. That way, the total entropy of the isolated system in which the open system exists still increases. A couple examples. Consider a puddle of water in Minnesota. During the night, the water freezes to ice. Oh, guess what? The order of the water molecules increased. That is, their entropy decreased. And they did so spontaneously out in nature and with no intelligent intervention required. I have a couple notes that I won't read here. That's just in case anyone wants to read it later. And another example is in star formation. You have a huge molecular cloud that collapses due to the mutual gravitational attraction between particles. And when it does, the particles become more concentrated, which involves an increase in their order. Here too, entropy decreases spontaneously out in nature with no intelligent intervention. So this just shows an example. This is a glass of water and you plop some food coloring into it. It starts off in a highly ordered state where it's all concentrated. The random motion of the water molecules will distribute that and disperse them throughout the container. And when they're the most randomly distributed, that's the greatest disorder. In the star formation, it's the opposite. You start with the particles all dispersed, and then gravity pulls them together and concentrates them. So the food coloring goes from high order to low order, greater disorder, but star formation goes in the opposite direction. And again, no intelligence involved, it just happens. The second problem with the argument is in regard to evolution, where's the isolated system? The mandatory increase in entropy associated with the second law applies to isolated systems, not open ones. For example, I just showed you a couple of examples where open systems entropy decreases spontaneously. A living organism is an open system, not one. And if we drill down into a living organism like an animal, organ systems are not thermodynamically isolated, and neither are organs, tissues, or cells. In a single living organism, there's nothing that's thermodynamically isolated. If we expand outward, populations of individuals are not thermodynamically isolated, and neither are communities or ecosystems. So there's no living system that's thermodynamically isolated, or subsystem, or collection of systems. I won't read this either, but the Earth also is not a thermodynamically isolated system. So back to their argument. Evolution, which involves an increase in order, violates the second law of thermodynamics, which says that everything changes in the direction of greater disorder. That's wrong for at least two reasons. Local decreases in entropy can and do occur spontaneously out in nature and open. And regarding evolution, there are no thermodynamically isolated systems. All levels of life are open systems, and not even the Earth itself is an isolated system. So there's no mandatory increase in entropy. That's not to say that entropy, we do need mechanisms in biology to quote unquote overcome entropy. Living systems have to stay at stay elevated above thermodynamic equilibrium, but that's a separate issue. Shouldn't have even brought that up. Okay, so now their third argument against evolution is, if humans evolved from chimps, then why are there still chimps? And you will also often see images such as this. And by the way, this comes from the catholiceducation.org. This is a bad image for at least two reasons. First, this appears to be a chimp, which would suggest that humans up here on the far right evolved from chimps. Science doesn't say that. Second of all, it gives the idea of a linear progression where the new species replaces the old one. Now, if this is chimpanzee, chimpanzees live with us today. Where's the chimpanzee in the modern time? Anyway, if you see diagrams like this, just realize that they're not accurate. They're not scientifically accurate. Okay, evolutionary biologists do not say that humans evolved from chimps. Chimps are not our parents, they are our cousins. Humans and chimps are both extant species. Extant just means currently living as opposed to extinct. Neither descended from the other. Chimps didn't descend from humans, humans didn't descend from chimps, but rather both descended from a shared common ancestor that existed a few million years ago. This is a phylogenetic tree, and this red dot will be the common ancestor. This common ancestor is neither a human nor a chimp. It's just where the lineage is split, and one through a bunch of intermediates led to humans, and one through a bunch of intermediates led to chimps and bonobos. So a better way to phrase that is if humans evolved from apes, then why are there still apes? But humans are apes. There's been a prejudice against this for a long time, just like you still hear people say that we're not animals. Well, of course we're animals. We are also, of course, apes, but even scientists refuse to accept that. There was some sort of humans are better than that, don't classify us as apes, but they finally came around and did the correct classification. Humans, bonobos, chimpanzees, gorillas, and orangutans comprise the great apes. There are also lesser apes, such as gibbons. Together, the great apes, which includes humans, and the lesser apes comprise the apes. Therefore, humans are apes. Humans, as well as chimps, bonobos, gorillas, etc., are extant apes that evolved from certain earlier, now extinct apes. Even if evolution were false, humans would still be apes. Anatomically, physiologically, embryonically, and genomically, humans are apes. We group right in there with the other apes. This is
If I might interrupt for a moment,
Sure.
Michael has put a comment in the chat. I'm not sure if you want to address that because I have no idea what he's talking about.
This is my first time giving a presentation. I don't know how to get the chat.
Oh, sorry. Michael,
It's just a clarification. The common ancestors, Paralipithecus, Caudalicus, they lived about 60 million years ago. It's just a random fact I threw out there for just because I wanted to show off.
yeah, thank you. We like it when you show off. Thanks. Sorry. Go ahead.
Okay, so this just shows that genomically they did whole genome, gap-free, what's the other word? Unitary? What do they call it? Unique alignments. And then they saw how closely related the genomes were. As you can see, humans group right in here with the other great apes. Okay, now the second problem with their logic is it's just poor logic. We can do analogous flawed logic. If Christianity came from Judaism, then why are there still Jews? If Protestantism came from Catholicism, then why are there still Catholics? If Mormonism came from Protestantism, then why are there still Protestants? The problem with their logic is this assumption that it's a linear chain and the new has to replace the old. But with evolution, just like the examples above of religions, oftentimes branching is involved, which allows both the old and the new to exist at the same time, side by side, into the indefinite future. And this is not the greatest picture, but at least it shows the branching that's going on, various branching for, here's the common ancestor of chimps and humans about 5 million years ago, according to this diagram. But you can see that there's splittings going on left and right. Continuing with if humans evolved from apes, why don't we see humans evolving from apes today? All the ape ancestors from which humans evolved are extinct. They do not exist anymore. This goes for the entire chain of ancestral ape species, including Australopithecines and the many non-modern human hominin species. The path that led from earlier non-human apes to humans cannot be replayed because the starting point and all the many intermediate steps no longer exist. So it's kind of like someone asking, if your great-great-great-great-grandmother produced children that led to you, then why don't we see your great-great-great-great-great-grandmother producing children today? Because she's long dead, as are all my great-great-great-grandmothers and all my great-great-grandmothers and all my great-grandmothers and all my grandmothers. So why would you expect that to be replayed? Those species are gone. Second, the ape species that are alive today, chimps, bonobos, gorillas, orangutans, etc., they are not the species, they are not the same species as the ancestral apes that we humans evolved from. Since evolutionary biologists do not say we humans evolved from species of apes that are alive today, no one should expect humans to be evolving from the species of apes that are alive today. And the third problem is that humans and other extant apes continue to diverge more and more from each other as time passes. The number of genetic differences between the extant species of apes continues to increase. So over time, we're getting more and more dissimilar from chimps and gorillas. But all of the extant apes are getting further and further away from the common ancestor we all share. So again, why would you expect it to replay if we're much further away now than we were at the starting position? So summing up these, if humans evolved from chimps, then why are there still chimps? No one says humans evolved from chimps. Chimps are not our parents, they're our cousins. If humans evolved from apes, then why are there still apes? Well, humans are apes, so are chimps, gorillas, orangutans. And evolution often involves a branching pattern, allowing both the old and the new to exist at the same time, side by side, into the indefinite future. Again, if Christianity came from Judaism, then why are there still Jews? If humans evolved from apes, then why don't we see humans evolving from apes today? 3 reasons. The original and all the intermediate species of apes are extinct. The species of apes alive today were never claimed to be our ancestors. And the species of apes alive today have diverged more and more away from the starting place.
Rick, I have another question for you.
Yes.
Embryos of other creatures, like water mammals, have similar early embryo development. Are you drawing all your conclusions on the predominant Darwinian evolution theory? I see that theory as kind of myopic, as there are so many unknowns. I think the aquatic ape theory has some good points.
Okay, I'm not basing it off of Darwinian evolution, as I've or in earlier meetings. Darwinian evolution is outdated, just like Mendelian genetics is outdated. It's from the late 1800s, and science continued for 150 years since that and has learned a lot more. There's often called a phylotypic stage during embryonic development, where, for example, all mammals look almost identical. They have shared characteristics. They have postanal tail. Our embryos have a postanal tail. They have, oh, wow, I've forgotten the names of all these things. Okay, anyway, but yes, I agree with that. All I know about the aquatic ape hypothesis is that I've read that it's not mainstream. That's all I can say about that without looking it up.
Thank you.
Okay. The fourth counter to evolution is they claim that there are no transitional fossils, not even one. And an animal in transition would be, for example, half crocodile and half duck, a crocoduck. Problems with that argument. We have lots of transitional fossils and more continue to be discovered every few years. We have fossils of intermediate species before all of these transitions, from fish to terrestrial tetrapods, from reptiles to mammals, from four-legged land mammals to cetaceans, whales, dolphins, etc., from theropod dinosaurs to birds, and from earlier apes to humans. So we have plenty of transitional fossils. This is a famous genus of fossils. The genus is Archaeopteryx. And you may not be able to see all this, but first of all, you can easily see that this has feathers. This fossil, by the way, is about 150 million years old. It has well-developed feathers, long, full, there's no gaps between them, all that kind of stuff. It has feathers on its tail also. The front limb is modified into a wing, and you can see it has claws on its front wing. It has a furcula, a wishbone. The clavicles have fused to form a wishbone. It has true teeth in its mouth, has a long bony tail, and it has an opposable hallux, opposable big toe, I guess you would call it. Okay, so the above is a picture of a fossil of famous transitional genus found just 2 years after Darwin published his first edition of Origin of Species. Archaeopteryx is a transitional genus having some characters of an ancestral group, reptiles, and some characters of a derived group, birds. While a child could look at a bird or a reptile alive today and tell whether it's a bird or a reptile, not even adults can do so when we go far enough back in time. The clear distinctions between bird and reptile break down, and the lineages begin to converge, with a single animal having characters that are found today in both modern groups. For example, Archaeopteryx had characters of birds, feathers. Well, birds have feathers, reptiles don't. Wishbone. Well, birds have wishbones, reptiles don't. Opposable hallux. Birds have opposable hallux. It makes it easier for perching on a limb, by the way, when that big toe can wrap around towards the back. Kind of like our opposable thumb makes it easy to grab our wrist. And wings. So that's obviously a bird. But then it has characters that are found in modern reptiles today, but not in modern birds. It has true teeth. No bird today has teeth. Now, there's a couple things. There's something called an egg tooth that some hatchlings have, but that's not a tooth. That's an egg tooth is as much of a tooth as a seahorse is a horse, or a starfish is a fish. It's just a term. It's not accurate. And then some birds actually have serrated beaks. So their beaks have been modified to have cutting edges on them that serve as teeth. But again, that's not teeth. No modern birds have teeth, but Archaeopteryx did. Archaeopteryx also did not have a beak. Birds have beaks. Archaeopteryx had a long bony tail with no pygostyle. Pygostyle is basically like our coccyx. During embryonic development, birds begin growing long bony tails, such as humans do too. But then a lot of the bones are resorbed, leaving only a small number. And later those fuse. In humans, they form the coccyx. In birds, they form a pygostyle. And then finally, Archaeopteryx had claws on the front limbs. That's almost unique to reptiles. As a rule, modern birds don't have claws on their front limbs. The only one I know of is called the Hoatzin, and even then it's only the young. So the claws disappear later in life. So what is it? Is it a bird? Is it a reptile? It's both. Also, the fossils of Archaeopteryx exist at the right time in the fossil record, after there's already theropod dinosaurs, before there's modern birds. And Archaeopteryx is not the only fossil we have supporting the evolutionary origin of birds from theropod dinosaurs. There's lots of them. Okay, and now what creationists often do is quote experts, actual experts, making it look like there are no transitional fossils. Creationists are well known for quoting scientists out of context. They quote Darwin out of context all the time about the eye and about the geological record. When it comes to the fossil record, the one they quote the most out of context is Stephen Gould. Their goal is to try to make it appear that Gould, possibly the most famous paleontologist in his day, said there were no transitional fossils. Gould objected in writing more than once to their tactics. Here's one quote from him from 1983, by the way. So first of all, they're using quotes from someone who wrote, what, 30 years ago? No, 40 years ago, almost. As if nothing in the last 40 years has happened. Anyway, Gould wrote, since we proposed punctuated equilibria to explain trends we observed in the fossil record, it is infuriating to be quoted again and again by creationists, whether through design or stupidity, I do not know, as admitting that the fossil record includes no transitional forms. Transitional forms are generally lacking at the species level, but they are abundant between larger groups. And this is just another quote. I'll leave it up here, but I won't read it because of time. But again, he's saying that there are fossil species. The third problem with the anti-evolutionist thing is that no biologist claims that a transitional species would have a modern duck's body and a modern crocodile's head, a crocoduck. The false notion that if evolution were true, paleontologists should find fossils of crocoducks was a silly claim made by anti-evolutionists. Kirk Cameron was one of them. The other one was Ray Comfort, and a televised debate. They had images made up of an imaginary animal with the body of a modern duck and the head of a modern crocodile spliced together visually, then disingenuously implied that evolution requires such chimeric forms. It was cheap theatrics and a standard straw man logical fallacy. Logical fallacy is where you set up a weaker, you don't attack the opponent's actual position, because it's like beating up a man, that's hard. But if you construct a straw man, you can beat that thing up really easy. So they take your argument, they distort it and create a much weaker form, and then attack that form, pretending that they defeated your actual argument. It's a logical fallacy. And here's Kirk Cameron on Fox News, looks like the O'Reilly show. Look at his face. This is what evolution says should exist. Where are they? We never find these. Now, they should have known better too, if they bothered to read Darwin's book, because in 1859, in his first edition, Darwin basically addressed this thing. I won't read all of it, but he says, I found it difficult when looking at any two species to avoid picturing to myself forms directly intermediate between them. But this is a wholly false view. He goes on to say that the intermediate species are between extant species and a common ancestor that could have lived millions of years ago, not between two species that are alive today. So for example, so with natural species, if we look at forms very distinct, for instance, to the horse and the tapir, we have no reason to suppose that links ever existed directly intermediate between them, horizontally. That's not how evolution works. Evolution, phylogenetic trees usually go, time progresses from bottom to top, and there's lineage splitting, all that kind of stuff. So to recap, their argument is there's no transitional fossils, not even one. An animal in transition would be, for example, half crocodile and half duck, a crocodile. We have lots of transitional fossils, and more continue to be discovered every few years. When creationists quote Stephen Jay Gould and other paleontologists, making it appear those scientists say there are no transitional fossils, the creationists are quoting the scientists out of context. Gould and other paleontologists know of many transitional fossils. And then finally, no biologist claims that a transitional species would have a modern duck's body and a modern crocodile's head, a crocodile. Kirk Cameron used cheap theatrics and a standard straw man logical fallacy. The fifth counter against evolution is that mutations are always harmful and always involve a loss of information. There are no examples of beneficial mutations or of mutations that added genetic information. Okay, first we need to be clear about what a mutation is, because when creationists, anti-creationists say a mutation, what they seem to picture is, picture a chicken born with two grotesque heads. That's a mutant. The genetic defects that cause that deformity are what some anti-evolutionists mean by mutation. A mutation is something that results in such a grossly deformed mutant. But that's not what mutation means in biology. In biology, a mutation is simply a change in DNA base sequence. In regard to evolution, that mutation, to be a mutation that counts, it then has to be passed on to future generations. Mutations can range from a single base substitution. So if you remember back to biology, you have like an adenine in a certain position. You have 3.2 billion base pairs in the human genome. If you have an adenine in one spot, that can be replaced by, for example, a cytosine. That's a simple mutation. It can go all the way up to whole genome duplications. In vertebrate history, there have been whole genome duplications. They're much rarer in animals than in plants, but they still have occurred in our evolutionary past. And mutations can be neutral, deleterious, or beneficial. It's not the case that they're all deleterious. One simple kind of beneficial mutation is a simple duplication of an important gene. Having an extra copy of an important protein coding gene can be beneficial since it can allow for more copies of the coded for protein to be produced in the same amount of time. So say you're producing 50 units per minute, whatever. If that gene gets duplicated, now you can produce 100 units per minute. Maybe that's advantageous. And this is, I'll explain one way that you can get a duplicated gene. During gamete formation of sperm and eggs or ova, there's a certain type of cell division called meiosis that occurs. And there's a certain stage called prophase 1 that occurs. Humans have 23 pairs of chromosomes, 22 what are called autosomes, and then the sex chromosomes X and Y. So let's just assume that this is chromosome 1, and the yellow is from your mother, and the blue is from your father. I'm going to have to leave some stuff out here, well, this would take 20 minutes to go over this diagram. So I'm simplifying it. The yellow is from your mother, the blue is from your father. So what happens during normal meiosis is that the chromosomes form an X figure, which is called a chiasma. Chi is just the Greek letter that looks like X. So in a lot of things in biology where there's an X shape, it's called a chiasma. For example, in your eyes, you have your optic nerves run straight back to the same side of the brain, but then part of them also cross over right behind your eyes. And that's called the optic chiasma because it's shaped like an X. So anyway, these X things form. When they resolve themselves, corresponding segments of chromosomes have been exchanged. So if you look on the right, the blue from the father's chromosome has been swapped over to the yellow chromosome, which came from your mother. And then the yellow from the mother's chromosome has been swapped over to the blue. So corresponding segments were swapped. That's crossing over. This occurs all the time during meiosis. It's a natural process. You want this to happen. It happened to every one of us in the eggs and sperm that produced us. However, now we're going to, this is a different diagram, so we have to swap a little. The left is still from the mother, it's blue. The right is from the father, is orange. In the other one, they lined up perfectly. A was exactly across from A. B was exactly across from B. But if you get a misalignment, then you can get unequal crossing over. So it's not corresponding segments that get swapped, equal size segments, but they can have different things on them that get swapped. So if we look at this chromosome 2 and run down, we have A, B, D. It has no C, D, E, F. So if we look over on the right at chromosome 2, it has A, B, D, E, F. The C gene was deleted. If we look at chromosome 3, we have A, B, C, its own C, plus the C from the other chromosome, D, E, F. So if we go to the right, we see A, B, C, C, D, E, F. That's it. Duplicated chromosome, duplicated gene. So meiosis, crossing over happens all the time. If they don't line up properly, you can get a gene duplication. And a simple gene duplication with nothing else can be beneficial. This is an example. You can read that, but I'll just give the general idea that there were a couple genes, and having more copies of those genes proved beneficial. It allowed these particular yeast to, what exactly does it say? To grow more efficiently. So that's a simple beneficial mutation. You have a natural process, gene duplication that can occur by unequal crossing over. If you get an extra copy of a gene that happens, that more copies of that protein would be beneficial. That's it, beneficial mutation. This is an actual example in a scientific peer-reviewed paper. Now we can go one step further. Gene duplication followed by divergence. And this is actually, it's a series of mutations. It's not a single mutation, but this is how humans, well, humans and other apes ended up with trichromatic vision. So opsin genes are genes that code for proteins that are in your retina, that absorb light, that are involved in the absorption of light. So dichromats have two opsin genes that code for two proteins, and these proteins effectively absorb at different wavelengths. One of the genes was duplicated, just like we saw above. It's easy to get a gene duplication. A couple point mutations, small mutations, in the copy produced a protein that was shaped slightly differently, and that allowed it to absorb light of a different wavelength. The result was we ended up with 3 opsin genes instead of 2, and we have trichromatic vision. We can see red, green, blue, and all the combinations of those colors. Now, important thing is that no new neural circuitry is required for seeing more colors. I have a link here to a YouTube video. They took monkeys and they did tests where there's a screen, and if they hit the red region, they get a treat. They couldn't do it. I assume they spliced a human gene or spliced some third opsin gene into the monkey, and the first generation could then detect red. So no new brain circuitry went on, just the presence of that opsin gene was enough for the monkeys to see 3 colors, at least 3 colors. And we can also do like phylogenetic trees, and we can see where the gene duplication occurred that led to trichromatic vision. As you can see, the great apes, humans, chimpanzees, gorillas, and orangutans have it, and so does the monkey, the macaque. And over here is an independent duplication. I do not know what an laude is, but anyway, an independent duplication that led to trichromatic vision in that lineage. And I'm not going to go over these, it'll take too long, but I'm going to just leave this here. Someone can, if they're interested. These are 3 different types of mutations that have been found in the human genome that lead to larger brains and or more complex brains. Chimps do not have these. These are mutations in the human-specific lineage that leads to increased brain size or complexity. beneficial. So their claims are mutations are always harmful and always involve a loss of information. There are no examples of beneficial mutations or mutations that add genetic information. Well, first we have to understand that in evolution, a mutation is just a change in DNA, and for evolution, that gets passed on to future generations. And scientists know of many beneficial mutations. Don't scroll, Rick. Scientists know of many beneficial mutations, including ones that add genetic information. So the gene duplication itself, you could probably argue that that doesn't add genetic information. It just doubles what's already there. But when you get to the trichromatic vision, that's a new gene. Gene duplication followed by divergence produced a third opsin gene that did not exist before. That's an addition of genetic information, and it was beneficial. And the same thing with the ones that led to increases in human brain size and or complexity. Not only were they beneficial mutations, but they added genetic information to the genome. Oh, I'm sorry. When I say genome, I've heard it pronounced a lot, genome, genomics, genome, instead of genome. I say genome. Okay, and the sixth argument, that's one, if I can get through it. They claim natural processes cannot produce information. Only an intelligent agent can produce information. Okay, so taking that claim just as it is, it's clearly false because many rocks that form through purely natural processes contain information, such as how long ago did the rock form? 65 million years ago, 250 million years ago? We can radiometrically date a lot of rocks. That information has to be in the rocks because we're getting it out of the rocks. Second, under what conditions did the rocks form? Did they form at the bottom of a shallow sea, along a shoreline, from dry sand dunes, at the surface by lava cooling? That's information that's locked in rocks, and that information got locked in there millions of years ago. And then C, what life existed when the rocks formed? Did the rocks contain fossils of trilobites, of T-Rex, of Australopithecines? So nature can produce information. So their reply would likely be, but rock information is not genetic information. Natural processes cannot produce genetic information. Only intelligent agent can. That's wrong because biologists know of several natural processes that can add new genetic information to genomes, some of which are gene duplication followed by divergence. If you remember, that's what I just covered about the origin of trichromatic vision. Exon domain shuffling, lateral gene transfer, it's also called horizontal gene transfer, endosymbiogenesis, and de novo gene formation. That's 5. Those are not all of them. There are more. I can't cover all of these. I could explain all of them if I had time, but I don't have time to cover them. I'm going to just continue looking at that first one, gene duplication followed by divergence. So here's an English analogy. You have gene A, tower. Gene A gets duplicated, tower, tower. One copy is mutated to a new functional sequence. So the beginning T in the copy is mutated to a P, tower, power. The new sequence for gene B will more than likely perform a function similar to that of the original gene. For example, the new gene may code for a protein that binds DNA a bit more strongly, or that binds a ligand substrate with a slightly different shape. But it will usually be a related function, not a completely new function. Gene families can arise by multiple rounds of duplication followed by divergence. I don't have enough room to show this, but you can follow what's going on. You start with tower. After multiple rounds of duplication and divergence, you have tower toad. So tower was duplicated, and then one of the letters was changed. You have power. Well, tower was duplicated, and the first letter was changed to a P. You have poker. Power was later duplicated, and the W was changed to a K. And then poker was duplicated, and then the P was mutated to a J. So you have a set of multiple genes that are related through descent, and many such gene families are known. One example, which I'm going to talk about in a second, is the globin gene family. So as you can see at the bottom here, there's multiple genes. There's about 7, 7 over here. There's 7 in the alpha globin gene family and 6 in the beta globin gene family, and they all arose ultimately from a single ancestral globin gene. So what happened? You have an ancestral globin gene. It gets duplicated. So you have 2 copies of the same gene. Now you have divergence. Mutations accumulated in copies that made them different. So they performed different functions, related but different functions. They were translocated to different chromosomes. Mutations can also involve chromosomal rearrangements where, for example, a segment of one chromosome detaches and attaches to another chromosome. So that's how genes can move to other, that's one way genes can move to other chromosomes. So now they ended up on other chromosomes. Now we can see further duplication, alpha and a duplicate with a sequence divergence, that's zeta. So we have alpha zeta, zeta duplicated, and then we have the original zeta, and then we have psi zeta. Alpha duplicated multiple times, and we ended up with psi alpha 2, psi alpha 1, alpha 2, alpha 1, and psi theta. Over here, the same general thing happened to beta. Beta was duplicated a couple times. There's divergence leading to epsilon and gamma. And then at the very end, we have epsilon, G gamma, A gamma, psi beta, delta, and beta. So this is gene duplication followed by divergence carried over multiple times. You get entire gene families produced this way. Now, it may have sounded fishy. Sounds too good to be true. You just mutate it, you just copy a gene, and then you mutate it, and you got new gene. Well, no, that doesn't always happen. A lot of times, mutations accumulating in a copy of a gene will produce a non-functional copy, which is what most people would probably assume. That can produce a pseudogene. A pseudogene is a false gene. It was a protein coding gene, but mutations accumulated in it and rendered it incapable of performing its original function. Now, if gene duplication followed by divergence does occur producing new functional genes, we should also expect to find pseudogenes as failed evolutionary relics. Well, do we find them? Yeah. For example, see this Greek letter psi? That represents pseudogenes. So if we go back to the one above it, all these genes in green, like what is that? Psi, I can't read that. Psi zeta, psi alpha 2, psi alpha 1, psi theta, psi beta, those are all pseudogenes. So they're protein coded genes that were duplicated, but when the mutations accrued in them, they did not hit functional sequences, they hit non-functional sequences. A paper published in 2021 states that the human genome has more than 14,000 pseudogenes. To put that into perspective, the human genome has only about 20,000 protein genes. So we have about 70% as many pseudogenes as we do protein coding genes. So there's the evolutionary relic evidence. We have the evidence both of gene duplication and divergence producing functional proteins and the relics we would expect, because that's not what happens all the time. So back to their original argument, natural processes cannot produce information, only an intelligent agent can. That's wrong because many rocks that form through purely natural processes contain information. But they would respond, quite rightly, I think, natural processes cannot produce genetic information, and only an intelligent agent can produce genetic information. But that's false, because biologists know of several natural processes. I list 5, there's many more: gene duplication followed by divergence, exon domain shuffling, lateral gene transfer, endosymbiogenesis, and de novo gene formation. And I believe that's the end of my presentation. Yes, it is.
Well, thank you very much, Rick. That was really interesting. So we'll open it up for questions now. Are you through sharing your screen?
I guess.
Okay. Michael has his hand raised.
Well, there's one more common one that you didn't have in there, and that's that scientists have never directly seen evolution happening, which is, again, one of those things that is not true. We have actually observed evolution directly happening.
Yeah, for example, there's a good YouTube video of a lab experiment. It's bacteria, but it's a lab experiment on a mega plate. And what they did was they took antibiotics that kill the bacteria, and they put them in different regions. So the first region was 10 times as much as kills bacteria. The next region was 100 times as much as kills bacteria. The next was 1,000 times as much. And you could see the bacteria grow rapidly till they hit that first barrier. But then mutations start happening, and you see a small breakthrough that comes out. it can now survive 10 times the dosage. And then they spread and they hit the next barrier and they all die off. But mutations keep accumulating until there's a small breakthrough. And then you see these populations spread in the 100. Well, that's mutation and natural selection, changing the genome of bacteria. And we see it real time. We have, well, not real time. It's a time elapsed over like 2 weeks, I think. But we have the actual videos that show that.
So, Rick, if I might, I forgot what I was going to ask. I'm sorry. One of the things that I always get stumped on is when they say that only an intelligent agent can produce, can change or produce genetic information. I always wonder, where does that intelligent agent come from?
Well, their argument is usually based on information. DNA contains too much information to rise by chance, is their argument. By the way, I had like 3 other ones, but I tried to cut it down to 45 minutes. There's too much information in DNA to rise by chance, but their intelligent designer would theoretically be all-knowing and would have more information than the entire current universe, and they accept that it just exists without a cause. But, you know, abiogenesis and evolution tries to start with minuscule amounts of information and increase it over time by mechanisms that we know work. So yeah, it's kind of self-defeating. Where does the information for their intelligent designer come from?
Exactly. That's all I've ever, that's how I became an atheist, was coming down to with them, where does God come from?
Yeah, you can do that for anything, the origin of the universe. We don't have an explanation yet, but God is, at least from a rational point of view, God is never the best explanation. It's always worse. If you use nothing else but Occam's razor, God is the biggest possible conceivable assumption you could ever have. If I claim, you know, flying magical unicorns magically poof something in existence, that pales in comparison to the claim that God exists. St. Anselm, God is that than which no greater can be conceived. Well, I can conceive of something greater than magical flying unicorns. So God is always the greatest conceivable assumption. So anything that relies upon God already is not the best explanation. Any explanation that is not impossible is better. So if we abductive reasoning, if we use abductive reasoning trying to get to the best explanation, God is never it. Even for the origin of the universe, origin of life, nothing.
So Mark has a question in chat. In discussion with religionists, they have argued that microevolution can occur, but macroevolution can't. How do you reply?
The usual counter is to ask them to explain a mechanism that prevents it from occurring, because it's not this simple. But in general, macroevolution is just microevolution accumulating over time. So what stops it from reaching that level? Plus, we have all the evidence. We were talking about embryonic evidence earlier. We have fossil records showing fish evolving, certain fish, not all fish, certain fish evolving into land animals, 4-legged land animals evolving into whales, but that's obviously macroevolution.
Right.
Evidence from genetics, from embryology, from fossil record, all kinds of things showing that evolution, macroevolution occurs. Macroevolution, also, the lowest level of macroevolution is speciation. And we have duplicated in the lab speciation events in plants that occurred in the wild. They found a species, they said, hey, it looks like these two separate species hybridized and produced this third species. They went in the lab, they crossed them, the offspring were infertile, the offspring were infertile, the offspring were infertile, but eventually they got fertile offspring. It's called allopolyploidy. The 2 genomes from these 2 different species combined and produced a new genome for a third species that could not reproduce with any parent species, but could reproduce with itself. So speciation has been validated in the lab, and that's macroevolution. And then you have to ask, and most creationists accept speciation these days, because going to Noah's Ark, You can't fit millions of species on the ark. So they go with kinds, and they say there's like 30,000 kinds on the ark, like a cat kind and a monkey kind. And then from this monkey kind, when it got off the ark, it produced all the monkeys we see today. Well, that's speciation left and right. In 4,000 years, by the way, that's hyper, ultra, super fast evolution, something way faster than what biologists say happened. But they are accepting speciation and large scale, tons of speciation. So what is their explanation?
Okay, Michael, you have a question?
I was just thinking there's one more that kind of goes along with what you're saying about how mutations can only be deleterious. There's also the opposite of that, the irreducible complexity argument, where they say that some things are so perfect that they could not have come through except through a intelligent designer, such as eyesight is the common example that they use. So.
Yeah, Michael Behe, in his 1996 book, Darwin's Black Box, is the one who introduced the term irreducible complexity. He's an intelligent design creationist, not a young Earth creationist. Irreducible complexity is defined by Michael Behe's 1996 book, has been experimentally refuted. In his book, if you have a system composed of multiple parts, if you remove any of the parts, and the system fails. Any single part in the system fails, it's irreducibly complex. It's complex because it consists of multiple interacting parts. And if you remove any piece and it stops failing, that means it's irreducible. You can't reduce it to fewer parts. Right. What scientists did was they had I don't remember the details, they had a 5-protein system. Some sort of ring is involved, but I don't remember the details. They took one of the genes, duplicated it, mutations in both copies then resulted in the 6th member being required. So at the end, they had a 6-member protein ring. Again, I don't remember what the ring did. If any one of those pieces was removed, the system wouldn't work. Where did that 6-member ring came from? It came from a 5-member ring by well-documented process, gene duplication, mutations in the copies. And the way they actually did this, I can't remember the ring, but some bacteria today have a 6-member ring, some have, and they used, I can't remember what they call it, but they went back in time using gene comparisons, gene alignments, or something like that, gene resurrection. We resurrected the ancestral gene saying, if we do things backwards, here's the ancestral gene, it has 5 things. Now we can see what happened to get the 6th. But anyway, his irreducible complexity has been experimentally refuted. His newest claims came out, irreducible complexity dealt with multiple beneficial mutations happening simultaneously. That is a straw man because they don't have to happen simultaneously. You can have mutations that occur and are neutral, and they can spread through a population by random genetic drift. And then if another mutation comes along and happens, and it's beneficial, it's possible that these pre-existing great variation within the population turns out to be beneficial. Beneficial is dependent on the environment. If you're familiar with sickle cell allele, sickle cell allele in the United States is generally harmful. Right. Where malaria is prevalent, sickle cell allele gives some protection against malaria. So it's actually beneficial. And what you end up with is, it's called, wow, I've forgotten the name of it, hybrid vigor. Okay. Anyway, so it depends on the context. Some places that sickle cell allele is deleterious. Some places it's beneficial.
Right.
These mutations that are spreading through the population, they're not beneficial yet. You have a beneficial mutation pop up. Because of the new context, there could be a pre-existing mutation that goes. His idea that they have to pop up simultaneously, I may not have explained it very well, but if you look it up, you'll see that was his edge. What was it? The edge of evolution? Something like that. He claimed there was an edge to evolution. Evolution can do all this, but it can't get past this point. And that was multiple beneficial mutations occurring simultaneously.
Rick, can I ask you to go ahead and close your screen because some of the sound's getting a little distorted for people? um, go up to the options and tell it you don't want to share anymore.
Okay.
Great. Now, Joe Reinhardt had a question. Joe, do you still have your question?
Yes, I actually just want to make a couple of quick points. One on the subject of religion, where they keep going back to the original creator. All religion ever does is move our ignorance on the subject back one more level. That's all it's ever accomplished. And I wanted to talk for a moment about the second law of thermodynamics. I'm always delighted when some creationist cites that for me, because now I invite them to tell me all about the laws of thermodynamics, of which they don't know a damn thing, of
You
which
mean
there are in
both of
fact,
them?
well, there are 5 of them, one of which is Zeroth.
There's 4 that I know of.
Zeroth plus 4 is 5 laws of thermodynamics.
Okay.
So
Yeah, but
that's
they
all,
think there's
all I
2.
know about them, but that's 100 times more than they know about them. It's always a good rebuttal to that argument, because you're talking about something you don't know the first damn thing about.
Yeah, the 0th law is something like if 2 systems are at the same temperature, heat energy will not flow between them, or something to that effect.
I have no idea what they are. I just
That's
know
the
that they don't
0th
know.
law. The first has to do with conservation of energy. The second has to do, it depends on how you phrase it, but entropy. And the third has to do with absolute 0, to the effect of all molecular motion stops if you get to absolute 0.
Okay. Is that it, Joe?
Yes, that's all I have. Just particularly the thermodynamics is of interest.
Yeah, that's a good point. I don't know anything about them either. Jim Peterson had a question.
Well, actually, it wasn't so much a question as a comment. I think, Rick, that your talk well illustrates the difference between science and religion in the approach to reality, to logic, and to reason. That is to say that a God that is essentially simple, that is omniscient and omnipotent and so forth, does not need the complex actions described in science to explain the world. It is the entire world, everything in it, everything that happens in it, is simply an exposition of God's will of some kind. But it is an invitation to ignorance. It is a way of telling people that you don't need to study the way things work. God is responsible. And in so doing, they have held back the advance of civilization for thousands of years. We may well be 2,000 years more advanced than we are now if we had taken or chosen the Greek way of looking at material reality at that point in time. So I think what you've done, Rick, is to well illustrate why it's important to study science, to understand the world, to understand who we are and where we came from. So thanks.
It's interesting that science, well, you didn't have atheists in the 1600s. But it's interesting that science branched off from philosophy, from religion and all, because of Christians, like Francis Bacon. He was a Christian, and he's one that's credited with the scientific method, or the general ideas of science. And it was Christians who started modern science. If they knew how it would turn out, if they were psychic and tell the future, I wonder if they would have done that.
I think not.
Somebody would have done it anyway. It had to come. Jim Young, you have comment or question?
First, I'd like to thank you very much for your presentation. It was a wonderful presentation, and I was glued to it intensely, trying to absorb every concept and point you made. It is difficult for the layman to engage a creationist, especially an apologist who is lying and cheating at every opportunity. It is extremely difficult to engage them on a level playing field, because the knowledge that you have is not the knowledge that a general lay person will have with respect to evolution. So I have struggled, and I am a person who does engage creationists, but I have sought a simpler method for doing so. And that method simply consists of appealing to the knowledge of the scientific community as a whole, knowing that 97% of the scientific community supports the theory of evolution, and the minor 3% consists of people who are religious. And the distinction becomes obvious when you realize that the only reason that 3% objects to the theory of evolution is because of their religion. And they allow religious faith to trump their scientific objectivity. So I do make that argument. It's a fairly simple one, and I don't have to be a scholar in science to present that argument. But I thank you so much, because you are obviously quite informed. I wish I knew everything you know about it.
But just to point out, I started off as a fundamental Baptist, young earth creationist, anti-evolutionist. Now, my thought was, I want to know what's true. If the Bible is true, it will not hurt to investigate it. If evolution really is a lie, all that studying science will do is prove to me that evolution is a lie. All that kind of stuff. I was out for the truth, or as close to the truth as you can get. As I studied, the first thing I had to give up on was a young earth. When I started looking at the age of the earth, science overwhelmingly, the earth is way more than 10,000 years old. It's about 4.5 billion years old. And there's a consistent history with like 6 mass extinctions throughout, separated by millions of years. There's fossils that are found in between those extinctions, all that kind of stuff. Consistent history, earth is older. So then I became an old earth creationist. And then more and more I studied biology, I started realizing that a lot of evolution is true. So I probably moved to what would be called an intelligent design creationist. And I defended Michael Behe, the guy I said Darwin's black box, and William Dembski and some other ones. I used to be on forums where I would argue on their side. As I kept learning, it was around 2001, I had a document saved somewhere, where I finally came to say, I can't fight it anymore. Evolution is a solidly founded scientific fact. One of the good things was I was debating people online, and debates back then were actual debates. Now it's just trolling. Everyone trolls. So you can't get in, but it was actually, hey, here are my points. And they would show that they had better evidence than me on everything and better logic. And of course, as I'm going through all this, my religious belief faded and faded and faded and faded. But even once I was a full-fledged evolutionist, I still was not an atheist. I was still studying the Bible. And it's mainly when I went back at page 1 of the Bible and started reading the Old Testament. Because the Old Testament is not just the Old Testament. It's not just the Jewish scriptures. Jesus refers back to the Old Testament time and time again. All the New Testament authors refer back to the Old Testament. Why not read the Old Testament? Oh my God, the Old Testament is scientifically refuted, historically refuted, morally refuted, logically refuted. It's just everything. And then I'm like, well, there's nothing left to believe in. There's nothing left here. It's a vacuous, empty thing. And then you start realizing, well, God's quite an extraordinary claim. What's the evidence that he exists? There is none. There's no valid, these are terms I keep using. I use this online all the time because I ask for valid, objective, positive evidence, because their evidence will be subjective. Well, I've experienced Jesus in my life. Well, if you look online, Hindus say that they have experienced Vishnu in their life. So that's subjective. That's not valid. That's no reason for me to believe. It has to be positive evidence, because that's the second thing they do. That's why evolution gets attacked so much. They can't support their position. So what they try to do is refute the other position, and then that by default makes their position true. But they can't provide the evidence for their position. And of course, the valid is just, you can't, there's evidence that the 1969 moon landing was fake. It's just not valid. It's not evidence that stands up to scrutiny when critical thinking is applied and all relevant information is taken into account. If you listen to just the evidence that they present for the fake moon landing, you could be convinced that the 1969 moon landing was fake. But you have to take all the information into account and look at both sides and objectively and unbiasedly weigh the evidence. And then it's clear that it actually happened. They can't do that for God. Plus, they have the burden of proof. The side that claims extraordinary beings exist have the burden of proof. If I claim the Supreme Council of Magical, Invisible, Flying Werewolf Zombie Mermaids exists, it's not up to you to disprove it. It's up to me to prove it. And until I prove it, you should reject my claim.
Oh, Rick, you have said, this is Judy, you have said that Darwin's theory is, I'm not sure you said not valid,
Updated.
but it needs to be updated or has been updated. In what ways has it been updated? Or if that's too complicated, I'm not sure.
Well, the simple thing is that Darwin had no explanation. This isn't how he's wrong, but he had no explanation for how new traits arise or how they get passed from generation to generation. He was working on it, but he was still working on a fluid theory called pangenesis, I think. So obviously he never read Mendel. They were contemporaries. Mendel read Darwin, but Darwin never read Mendel, because if he had, Darwin wouldn't be sitting there on this false idea of blended inheritance. He would have, dang, look what Mendel did. That's right. So, so he had no explanation. When population genetics and all came up in the 1930-ish and 40-ish era, then they combined population genetics and all with Darwinian evolution and came up with what's called either neo-Darwinian evolution, the modern synthesis, or something like that. But even then, they didn't know everything. For example, something called reticulate evolution. When you go back to the simpler organisms, such as bacteria, we're all familiar with vertical evolution. You have two parents, they have children, and the genes get passed from the parents to the children. But then we learned in like bacteria especially, things can be passed sideways, horizontally. So you can have one species of bacteria and a different species of bacteria, and they have what's called a sex pilus. It's just basically, and simplified, it's a tube, and the tube is injected from one bacteria into the other. One bacterial genome is unwound, it's kind of circular. Part of it unwinds and is passed through the tube and makes it into the other bacterium. It can be from a different species. This is how, by the way, like genes for resistance to certain antibiotics can spread between different species, called conjugation. So what it turns out is there was a lot of evolution that was not vertical, which is still in the neo-Darwinian view, that's how evolution worked, vertical from parent to offspring. But then we found out there's all this horizontal transfer of genes, especially when you go back to the root of the tree of life. And that kind of threw the root of the tree of life into chaos. It's a tangled mesh. It's not a nice branching tree like you get if you start from fish and go forward. You have a nice branching tree. But before that, when you get back to the oldest organisms, bacteria and all, there's a lot of horizontal gene transfer. There's other things he didn't know. Off the top of my head, that's some of them.
That's good enough. Thank you very much. Michael, you had a comment or question?
Yeah, I think kind of in light of what you just said, actually this might be kind of an interesting question to ask you, since you have this sort of conversion from a dogmatic view to a scientific view. One part of the question is 25 years ago they had that flock of dodos. I don't know if you're familiar with that. They made an interesting point in there where they were saying that one of the reasons why a lot of creationists are so averse to adopting the more scientific view is, as we mentioned before, is that it's just so much easier to understand the creationist view. I mean, there's no specialized knowledge. You don't have to know anything. You just got to know God does it all. You don't have to know anything about, embryogenesis or genes or, splicing or anything, technical terms. And, and he made the argument that scientists are not as charismatic as like preachers and getting their message out there. You know, when I'm in front of my class, you know, I'm not worried about how much my students are going to like me, but like when you're a preacher, you kind of got to worry about that a little bit more because that's sort of your bread and butter. People aren't liking you, they're not listening to you. Whereas, you know, with scientists, I could say, you know, the facts are behind me, but, you know, if you're saying that God, you know, is speaking through me, you got to be a little bit more charismatic. So, I mean, part of my question is like, how could science be more approachable to creationists? And the second part of that question would be, you know, what you were talking about here, and I think you kind of touched on this a little bit when you were talking about your own conversion experience, or this is like not just a difference between making people see a scientific view, but making them actually change their worldview from a dogmatic view to a scientific view. And I mean, you personally went through that. I mean, do you think, how would you approach somebody who's coming from like a very dogmatic view and trying to get them to switch to a more scientific view when, you know, they're probably going to be very resistant to that?
Yeah, it's a good question. The first thing, I guess one of two things. First, I would ask them why they believe it. Can they explain, can they justify their belief to me? When they give me something like the Bible says, and then you can't reach everybody. That's just a simple fact. If they're resistant, what's called a Cryptian dogmatist. Cryptian dogmatist, you're one of these people. La, 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 la. Cover your ears, close your eyes, don't listen to anything. Any evidence that contradicts your view bounces off of you. You don't even entertain it. So they first have to be at least somewhat open-minded, but ask them, what is their justification for their belief? And if they say the Bible says so, and then point out, okay, well, how's that different than a Muslim believing the Quran or a Hindu believing, I don't know the name of their holy text, Vedas? I don't know. Thank you. I really need, I always want to bring Hinduism into my discussions, but I never know the words or anything like that. Thank you. But how is that different? And they can't give a good explanation. Well, then why is your belief any more grounded than their belief? And just something like that. And the other point I'll put up, one of the main things that stopped me quickly becoming an atheist is the atheist part, was ethics. My view was, I understand what's right and wrong because the God of the universe, the creator of the universe, tells me. What grounding can you have for ethics than that? You pull that out from me, it's based on random whim. Do whatever you want to do. I think another thing would be to teach them about philosophy of ethics. Again, that's complex. You have to read multiple books on it to learn about the philosophy of ethics. But they need something to replace their grounding in ethics. If you just tell them, oh, you get your books from you get your ethics from a God who killed everybody in a flood, who said slavery is okay and all this kind of stuff, that's not the same as giving them a replacement for it. They need a replacement so they can believe that or accept that morality does not have to come from a God. That was a big stumbling block for me. For weeks, I was on the internet begging people to give me the information I needed.
I'm just curious, did you ever go through like a phase when you were arguing that science was a belief system on a par with religion, which I see a lot of people doing?
Well, just that evolution was a lie and that scientists, and don't you know that most scientists reject evolution? And don't you know that most scientists say that the earth is only 6,000 to 10,000 years old? It's just these atheist scientists over here. That was what I was taught, and that's what I believed because my pastor told me. And he pointed me to some creationist, young earth creationist sources. And when I read them, that's what they were saying.
No, because I hear this argument a lot with my religious students where they will say that science is just another religion and that is based on belief just as much as religion is.
Well, the first thing I point out is look at in the last 200 years, science has taught us more about life in the universe than all religions combined did in the last 10,000 years. I have over here on my bookshelf, I have some molecular cell biology textbooks from college, 1,000 pages thick. None of that came from the Bible. That all came from science. I have a book somewhere up here on geology that's several hundred pages thick, Introduction to Geology. Where'd that come from? The Bible? No, that all came from science. books on genetics, books on astronomy. Well, astronomy is kind of different. There was knowledge of astronomy before modern science, but cosmology, just almost everything, almost everything we know came in the last 200 years. Science has a proven track record that religion doesn't. And a lot of that is because science is open to new information. Another one you hear a lot is that science is always changing. Trust science because it's always changing. Yeah, but it's changing better.
Precisely why you can trust it.
Right. Most of
If you are pleased with our programs, please tap the like button and then subscribe to our channel. Don't forget the bell so you don't miss any notices of new material. We usually post new content every week. See our created playlists to discover events thus far this year, or to see a list of topics and speakers from our rapidly growing and diverse collection since 1992.